someone leave this turned on all night? Because if someone left this turned on all night, then...
No, I put the battery back in and plugged it in.
Oh, you took the batteries out?
Well, no, the case was open. Maybe that's why. No, that's right. No. Yeah, we could start.
Built your leaderboard. Flat data.
How strange.
And are you watching?
Yeah.
It's on now. Playing. Started TV text, it's not getting worse. I think I should lower it four eggs down a little bit. It's like chugging.
That's true. It's like a blend.
Did we not find a...
No, there's no battery.
We should tell people that they have to be quick. Oh, of course I brought the wrong thing.
That's what I want to Go back. No. Use that. The next time I start.
I do have some gaps though.
I may not build a full time.
Yeah, but otherwise it's
I haven't had coffee yet, so.
All right. Good morning, everyone.
I also know that it's first thing in the day, so if you're anything like me, you're not fully awake yet. I have restrained from caffeine so far, so I have a starting point. One of these packs that, this isn't just my responsibility, it's like a whole team of people working on this. This is kind of the workflow that the folks, especially at UW, with progress, if you will. And the fun part is that all of this for each visit needs to happen within a minute for every new image, like automatically, like as the data comes in. So it's a really cool problem, but it's like a whole different level from what I was working on before, which is mildly terrifying. So that's kind of the end. So just briefly, I feel like I would be remiss if I didn't tell you all about how wonderful LSST is, because it's going to be really sweet. The idea is it's a 10-year survey to map the whole southern sky in 6 different color filters. This is a say in words, and bajillions of galaxies and stars, with tons of astrophysical amazingness that we can discover, of course. I'm excited for. That's not fully built and realized yet, because we don't have the data for one. But the idea is that you shouldn't have to download our data and install our software on your own computer to use our tools. And really briefly, so the software stack that I'm working with, I've gone from let's write a Python script to, oh God, lots of other people have already written lots of Python scripts. I should figure out what they do, which is a very fun problem. Our documentation game is getting better. It's still kind of catching up to where the software is, but most of it's Python. There is some C++ for some of the numerical behind-the-scenes stuff that needs to be a little bit faster. We're almost fully Python 3, depending on exactly what you're trying to do and who you talk to. Everything I do is pretty much in Python 3. And this software stack is basically what you'll need to either have on your computer or log into a server that has it, and then you can import all of our functions and run your own code as well. That's what we're calling this level 3. So really quickly, I want to give you an example of something I encountered pretty early on working for LSST. If you've ever done photometry, you've probably done image arithmetic, right? My life was IRAF. I would error, you cannot do that. So very early on, I encountered what was incredibly frustrating. I thought I was doing the most simple task, subtracting images, since that very first attempt. And so now I'm working on kind of linking together several of these steps. So I can now access images in Python, like an image that has all the different sources that you've found that have potentially changed between the two images. And then, of course, as always, I emphasize that writing a quick program to do a thing is not bad. That is how you learn, right? I'm not expecting anybody to start writing their first, multi-hundred. That is fine. That is a very fine tool to use. But in my case, it was not something that I learned at all. And so I was using Python, using MATLAB. It was okay. He wasn't you can't be my student anymore. I've also found that sharing code on GitHub, really does prompt spontaneous collaboration. I've gotten emails from people, even for the code that I was showing you at the very beginning, that just for a specific telescope, and they're like, oh, I'm trying to use this telescope. It might not seem like that big of a deal. And these best practices that you kind of develop now are going to serve you a lot in the long run. So I think it's going off. We want to be able to send that out to the community in a real-time alert stream so that folks can then follow up on things that they think are important.
Why 60 seconds rather than 5 minutes?
Because
Is it really that handy? Because in LIGO we have
a
a lot of
I hear
effort
what
into
you're saying.
getting data out as quickly as possible, oftentimes more than we actually needed to. The amount of work needed to do that is
Fair.
enormous.
Fair. I mean, I guess if it was 5 minutes, it wouldn't be the end of the world. It's mostly just that then, you start getting concerned because you just get them as they're coming in. Yeah.
Is there any work being done in terms of usability of the theory?
Still kind of flailing a bit in the, I can totally write a start to finish step-by-step instruction. But that's something that I maybe are still Python too, but that that you don't change responsibility, so I haven't really worried too much about it personally. Yeah,
So you're Python.
yeah, I'm 100% Python 3 whenever I do anything with the stack. So, Python. I mean, it's not Python 3 and Python 2. They have it's all Python, but there's enough things that are different when you're trying to make it.
To talk about the C, SciPy environment application, first I have to give you a quick introduction to space weather, and then we get into a motivation for developing C, some main features of C, and by the way, who we are, and at the end. Well, we all know that the sun is a big sphere of extremely hot plasma with internal convective motion that generates fueled via dynamo process. So we have a dynamo in the sun, and this is our structure of the sun. We are particularly interested in this photosphere here, where some of the phenomena that occurs on the sun appears in the Earth. So we are particularly interested in three phenomena: coronal holes, solar flare, and coronal mass ejection. I'll talk to you now. Well, remember that I told you that the sun is a dynamo. So we have changing magnetic fields every time in the sun. So these magnetic fields causes what we call the sunspots. These spots here. And these sunspots are temporary phenomena that occurs on the photosphere, on the sun, the visible part of the sun. And they appear as dark spots because they are cooler than the other regions of the sun. And, well, in these spots we have concentrations of magnetic field fluxes. Okay. Beyond the solar spots, we have also the coronal holes, which are results of solar activity too. And they are areas where the sun is cooler, like this. So they appear darker than the other parts of the sun. These coronal holes allow the solar wind to flow freely away from the sun. So it goes from the sun to the earth eventually. So remember that the sunspots are magnetic fields, so they can have different polarities. And these polarities, when they come together, they make this arc, this magnetic arc. So when these arcs break, like this, they form an arc, and this arc eventually breaks, it releases a flare. So these flares are coronal material, which is protons and electrons, and may be ejected at high speeds, about 500 or 1,000 kilometers per second. And we call this phenomenon coronal mass ejection. Okay? Well, this is, in fact, we have 4 pictures in different instruments that show when these arcs are created and when they are released. You see, these images are from the photosphere, and these two are the magnetic. Okay. One of these impacts are the auroras in the North Pole and in the South Pole. Okay, here we have some of these effects. So these explosions can damage satellites, or they can interfere on GPS, or they can interfere on telecommunications or pipelines, oil pipelines. They can induce currents and so on. So we have, it's interesting that some researchers do this by hand. So they carry the main database and download the image and then process the image or the data. And this is very stories with specific instruments and measurements. And we also can create light curves. These are the two main. Okay. We also can have light curves. Light curves is very important for us in some of our research. Okay. So explosions come from level C. It's not that problem, but M or X are very dangerous. So we can see there's an explosion, and we can get this data to another software that we use to predict the explosions. So it's As you see, it's a temporal series. Well, some of the data that we get give us something like this. And then we can, another possibility with the C is to perform image process for filament detection. In the group, it's the high performance. So I usually work with high performance systems. And my partners, they work with the data mining and so on. And so the first is contributions to predictions of solar flare CMX using neural network and image analysis. This is a PhD thesis. It's on the middle of the work. And we have nice results. Yes. Predict with too much, the interval is not too big. We can predict with 90% of certainty with 5 minutes in advance. But not more than this. So when we have an explosion now, we can predict and we can, in 5 minutes, we can do something like turn off the satellites and hope nothing. But we are improving. We have some results like 50% of certainty within 20 minutes or 30 minutes. But 50% is nothing more than flip good results for this. Now we already discard some of these magnetic characters. I mean,
Yeah, it's in the browser right now. See the up arrow down there where you opened it? Go to show in folder.
Yeah.
And then open it as a right click on it. No.
Why is it opening your internet explorer?
Default.
Yeah, it's really
If you right click and
So
you
go
open
back
it.
to the folder. Yeah, close, and then
Let's try that. And oh, this is all information if they want. And so the first thing that I thought I should at least try to define is on conference, because, and then you sort of try to work through them together, rather than just having someone who like unidirectionally gives you information. Opposed to that, a sprint. I pulled this from someone on Twitter, but I don't know who it was because I